Hey everyone, so it's raining here again today, so it is the perfect weather to sit back, relax, and do some set theory. Okay, so I'm here with my cat pillow, snuggled up, ready to do some set theory. And today we are talking about intervals. So what are intervals? Intervals are a type of way of representing sets of real numbers. Now, sets of real numbers, by their nature, they're infinitely big. So we need special types of notation to write them down. So let's have a look at how to do that.
Let's try and understand the difference between these two sets here. So they're both in set builder notation and they both have the same condition. So they're both sets of numbers where the number is represented by the variable x, and they both have to be between 1 and 5. But the difference is that one set is from the integers and one set is from the real numbers. That's what these z and r mean. So that's going to end up really affecting the composition of these sets. So let's have a look at what is in the first set, the set of integers, such that the integers are between 1 and 5. So this would simply just be the set of integers between 1 and 5. So 2, 3, and 4. And you'll notice that 1 and 5 aren't included because we have a strictly less than sign. But on the other hand, we can't possibly list all the members of this set of real numbers between 1 and 5. Because where would we start? What would be the starting point? So we know that 1 can't be the starting point, right? Because 1 isn't included. But maybe we could do 1.1. Well, that's not the first real number in this interval, right? Because we also have, well, 1.01. But that's not the first one either, because we could have 1.001. And you can see this could go on for a long, long time. So let's write these numbers down on the number line. So let's draw a number line. The interval that this set here represents would be between 1 and 5. So let's try and map out that interval. And you'll notice that we are using the open circle here, and that's meant to represent that 1 and 5 are not included in this interval. Okay, so let's look at a different way to represent intervals of this type, so where they come from the real numbers. So we've got the parentheses with two numbers separated by a comma. That's what's called interval notation. So this notation is how we represent intervals of real numbers. So how we represent sets that look like this, where the variable is from the set of real numbers, and the condition tells us that x has to be between a and b, where a and b are two real numbers. So this would be a perfect example of it, right? So x is a real number and it's between 1 and 5. So we could represent this in a more compact way as just by saying the interval from 1 to 5.
Okay, so the most important thing you need to know about intervals is what type of bracket to use. So you use the curvy brackets, the parentheses, to say the boundaries are not included, and you use the square brackets to say the boundaries are included. So let's have a look at that distinction in a bit more detail.
So we have at least two different ways of writing down intervals. So we can use the number line, as we did before. So we did an interval from 1 to 5. And then we use circles on the boundaries of the interval, and then just a line between those two boundaries. And then we have what's called the interval notation, where the two numbers representing the boundary are separated by a comma and then enclosed in brackets like here. Now this interval tells us that 1 and 5 are not included in the interval, and that's represented by the curved brackets. So this means not inclusive. In the number line notation, we represent that by the open circle. So let's see if we can write down different types of intervals where the boundaries might be included. Okay, so here's some different kinds of intervals. Here we have the interval from A to B, where A and B aren't included, and that's signaled by the curved brackets. And the definition tells us that they aren't included because we have these less than signs, strictly less than signs. So if we were writing that on the number line, we would use these open circles. Now, the next one is slightly different. We have the curved bracket on the left, so that's telling us that A is not included in the interval, but on the right, we have a square bracket. So the square bracket corresponds to a less than or equal to sign. So the B is included now in the interval. The A, on the other hand, is still not included. Okay, and if we were to draw this on the number line, we'd still have an open circle for the first boundary because that's with a curved bracket. For the second boundary, we'd have a closed circle. Let's look at the next one. The next one is just the reverse of the second one. So the second boundary is non-inclusive, and you can see that with the strictly less than sign. But the first bracket is a square bracket, so it's telling us that A is included. So you can see that with a less than or equal to sign. So if we were to draw this one, the first boundary would be closed, and the second boundary would be open. Okay, last one. Here we have double square brackets. So that's telling us that both A and B are included in the interval. We have a less than or equal to sign, so both of those correspond to the square brackets. And if we were to draw these on the number line, we would use two closed circles.
Okay, so that's about it for intervals. Nothing super complicated. If you've got questions, make sure you let me know in the comments. Otherwise, I will see you next time for some more set theory. Thanks for watching, everyone. Please remember to like, subscribe, hit the notification bell, support the channel so I can continue bringing you more great content.